Hello, and thanks for coming to this talk. I know it's a bit of a tough time slot as I'll be competing with your stomachs for your attention, but I hope I can still do that. All right, so today I would like to I'm going to be talking about a different method, let's say, of deploying applications, not just sending a binary installer to people, but actually serving QML content live. So a little bit about myself. I've been using Qt for quite a while. I've been using Qt since 2001 in a number of different contexts, whether it's classic desktop applications, mobile applications, or embedded devices. I'm an occasional Qt contributor, and I don't know if you recall Lars's presentation on some new features in Qt 5. One of them was the QDNS lookup class, which I had the pleasure of contributing to Qt. My job is I'm in charge of the software development team in a French internet service provider called WeFirst, which provides internet service to students mostly. And part of the package which we provide to students is an instant messaging application and voice over IP application. And this application is written is a QML application, and this talk is kind of my way of giving it some kind of feedback on how we deployed our QML application and what lessons we learned from this experience. So I'll be first kind of trying to set the scene with why would we want to serve an application over the network, then give you a brief overview of what Qt technically provides, Qt Quick provides in terms of network transparency, then gives you a couple of guidelines basically when designing an application which will be served over the network, and finally give you some deployment considerations, mostly, let's say, there's mostly server-side considerations to take into account when you're doing this kind of deployment. So the first question I'll try to answer is, what's the point? Why would one want to serve applications over the network? From this point on in the talk, when I talk about the network, you can assume I'm talking about serving applications over HTTP, but I mean other protocols could be used. But the easiest way to go is just to use HTTP. So just to give a bit of context. Where did my snake go? Damn it. Okay. The slide dropped out. So let's say, what's the typical life cycle of an application? The typical life cycle of an application is that let's say, you'll start by doing some development work. So at this point, only developers are involved. You will so you'll code your application and iterate locally on the developer's machine and see basically run through your application. The next step is you'll probably have a set of friendly users. Let's say you'll be dog fooding your application to a set of friendly users. And to do this, there's a step which you need to do, which is to basically package your application for the various platforms which you are targeting. So this can involve creating the installer for Windows, your DMG images for Mac OS, and well, okay, basically whatever the mechanism is for installing an application on the platforms you're targeting, you're going to have to do some per platform work. Next, you can push then this application to your friendly users. You'll probably have another round of iteration where you go back, fix based on some feedback, you're going to change some things. And so you loop again. You have to go through the steps of creating your installer again for the new iteration. And finally, at some point, it's going to get pushed to your end users. And so, what are the options for handling the updates of your application as it evolves and as new releases, as new versions come out? The first way you can go is to count on your users to maintain their application up to date. But the sad truth about this is that a lot of users just cannot be bothered to download the application. Possibly they don't perceive the benefit of the new version that you're offering, or it's just tedious. And even if you have let's say an automatic notification which says the new version is available, click here to install it, chances are that you're not going to manage to push your new features to your users, and you're going to progressively end up with an installed base which is more and more heterogeneous, and which is going to hold you back in terms of innovations. The happy path would be to have just automatic updates, which is fine if you're targeting platforms such as well, let's say just Android for the moment, because and later on iOS in 2013. If the platform does not provide an application store and its own auto update mechanism, the burden will be placed upon you to develop this automatic update mechanism. It's going to be a per platform development, and you're probably going to be running into things like problems with permissions, because regular users probably do not have the necessary permissions to perform an installation. For instance, in Windows, there's the dreaded user access control dialog, which will come up and say, are you sure you want to install this? You need extra privileges to install this application. And so if you want to address this, you're going to have either you're going to have your application which is running with elevated permissions, which is probably not something you want to do, or you're going to have to come up with another mechanism whereby you have an ancillary application running as a service in the background, which will handle the permission elevation and which will be allowed to do the automatic installation. When I describe this, I'm thinking of things such as Chrome, or let's say Chrome or Mozilla, which have done a good job at having transparent updates, but it's hard. If you need to convince yourself, go and look up the Omaha project from Google, which is the basis they use for the auto updates for Google Earth or for Chrome. And even a big project such as Firefox took a long time before they got to the point where they could deliver automatic updates. Basically, updates are hard, and they're the sources of headaches. So is there something different which we can do in the case of QML apps? So the typical anatomy of a QML application is that you'll have some C++ code, which is both, let's say, the wrapper which launches, which instantiates your QtQuick view. And this is native code, and you're going to have the usual deployment constraints. But on the other hand, you can have a lot of your code which is QML and JavaScript and the associated resources. So I'm thinking of things such as images or other kind of data. This code is totally cross-platform and interpreted. So which is one advantage. It's conveniently split into multiple files. So if only part of the application changes, well, this is probably isolated in a subset of all your files. And finally, QtQuick has built-in support for loading QML and other files over the network. And so this is something which you can leverage by basically having your if you keep your C++ code with a given version of your C++ code, you can iterate on the QML, and you don't even need to ask your users for the update. They launch their application, and bang, they'll get the latest version of your code. So some benefits of doing this. Okay, I mentioned let's say the cycle, the iteration cycle for the releases. You can move to a web-like mode whereby you change your QML files on the server side, and whenever whenever a user launches the application, they're automatically going to be running the latest and greatest version of your code. When you push a release out of the door, there's always the chance that you've missed something. There's this subtle bug which is just located in this one area of the code, and so you're kind of faced with a trade-off between, should I just hope the users don't run into this bug, or am I going to push another release out with the risk of eroding, let's say, the goodwill of your users to actually install updates? I mean, I'm sure some of you have run into these kind of questions, and they're kind of painful trade-offs. Another benefit of serving your interpreted code over the network is that you can have a progressive rollout strategy whereby a certain percentage of your users keep on using the previous version of your code, while some lucky few get to run your latest and greatest version, which kind of helps you mitigate if you get some negative feedback. It's still time to kind of to switch back to the previous version. And another benefit, which is really let's say which is common in a web-based world, is that you can do split testing. So you can have two slightly different versions of your UI, and give certain users, category A of users, a certain version, category B another version, and you can compare satisfaction results, or basically get some sort of comparative feedback between the two versions which you're offering. You can also have some time-limited changes. How many of you run VLC? The media player? Okay. You've probably noticed that around Christmas, they have a Santa hat appearing on the icon, and it has a slightly different look. Okay, this is fine, but it's hardwired into the code. And if tomorrow they decide to have a special Easter version with a bunny jumping around in the application, they need to think this out before they ship the release. Whereas if you serve it if you serve your QML code on the fly, this is something which you can decide later on. So now I'm going to talk about what QtQuick offers in terms of network transparency. By network transparency, what's meant by this expression is that the code is going to load and run in the same fashion, whether it's local or whether it's being served over the network. So first of all, I mean, when you create your QtQuick application, whether you're running Qt4 or Qt5, you start by giving your QQuick view or your QDeclarative view the path or a URL which gives you which designates where the QML has to be loaded from, and this can be an HTTP URL. So I mean, this is just quite straightforward. So okay, that's the basic. Let's say that's the first thing which you're going to need. You're going to be loading your first QML file. And there are also a number of elements inside QtQuick which come with a source property, which is also a URL. And once again, you can either give local file // files, or QRC for if you're if you're loading from resources built into your application, or you can use an HTTP URL. So the types, the QML elements I'm thinking of are image, so just for displaying an image, a loader, which is for loading a QML component, or font loader for loading fonts. I'll come back to font loader a bit later on because there are a number of quite cool use cases for using a font loader. Beyond the source property, what these elements have in common is that you have some sort of feedback because you have a status property which tells you whether the element is currently loading its resource, whether it has succeeded or whether it has failed. So this kind of allows you to react to these events. When you give a URL to these different elements which I talked about, you can either give a full URL, so let's say file-based URL, or an HTTP URL, or you can just give a relative URL, in which case the relative URL is resolved relative to the location of the current QML document. So let's say we need to load a picture of a head. We have this same code which just says, okay, go ahead and load head.jpg. And if this is on your hard disk, well, the head.jpg is going to be interpreted as being your home in Bob's home directory because the initial QML file was there. And if it's served from a web an HTTP URL, it's going to get resolved to relative to that URL. This is kind of cool because it means that when you're whether you're during the development phase or the production phase of your application, you can use the same code, and it basically depends on what the URL of your initial document is. Everything is just going to follow, and so you're not going to have to worry about rewriting all the URLs for your elements. You can also serve QML type declarations, but let's say you've created this new button element component which you want to reuse. There is a little bit of extra work to be done over just using this QML file locally. Is that you need to declare you're going to need to declare the names of your QML files, for your different components. The reason being that for local files, QtQuick can run over directories and check whether a file is present. If you needed to do this over the network, this would be a costly and slow process. So you basically have a sort of a manifest file which gives you which lists the types which you are declaring. You can also serve JavaScript code if you're most likely you're going to have part of your UI logic encapsulated in JavaScript files, and you can also import them. And once again, this path will be interpreted relative to your document. So one point which is missing, which we ran into, is the fact that if you want to, most likely your application is going, if it's for multicultural or multi-language environment, you're going to need to have some internationalization. The problem is that currently in QtQuick, you will need to provide this this translation file and load it from your C++ code, which kind of breaks the logic I was talking about of having all your UI logic and related files on the network. But it's really not that hard to write your own translation loader to be able to load arbitrary translation, load and install arbitrary translations from QML. I've given the link of a change I proposed for Qt5. I need to follow up follow up on this a bit, but basically, what do all these loader elements have in common? They usually go and fetch a document. They need to be able to follow redirects, which is something which the image and loader elements already do. So we need to mimic this behavior, and you need some kind of feedback in the form of a status property, which tells you whether what the current loading state of the translation is. So once you've got this in place, you're now able to you now have all the building blocks to start developing your application. So when you're building an application which is supposed to be served over the network, I mean, there are some just general recommendations: splitting the models. Let's say your data from the presentation is just a general guideline. It applies even if you're not going to be serving your code over the network. You have what I said initially was that the C++ code is still going to be deployed with the traditional mechanisms, native installer mechanisms. So you need to be kind of conservative in with this code, because okay, obviously the loader needs to be robust if you need some retry logic. In case you fail to load your QML file, you really need to get this right. You're probably going to be exposing custom elements which you write in C++ and then use from the QML code. Well, you're no longer dealing with, let's say, a self-contained package with your QML and your C++ code. You're going to become your own API consumer in a certain way, and so you're going to need to start thinking about API design, and you're going to need to keep your API both simple and stable, because otherwise this means that with the different versions of your C++ code, you're going to need to change your QML code, and so you kind of lose the flexibility which you had initially gained. All the rest, which is not C++ code, just serve it over the network. So this is just the anatomy. I mean, a simplified version of what an application can look like. You have the code. The bottom circle on this diagram is the code which is in which is the native code which is running, which is on your end user's computer, and what's at the top is what's being actually served over the network. So when you start your application, it's going to be loading a QML file. Let's say it's called main in this case. This QML file is probably going to be using the C++ plugins which you wrote. So that's something which is local. It's probably going to be loading other QML files and images and possibly also fonts. So this is kind of let's say the breakdown of the application. What's the function of let's say the C++ application code? It needs to set up a QML view. It also needs to if you have any initialization to do on the QNetwork Access Manager, which is going to be used to load your resources. This is also part of the C++ code's job. And in its simplest form, it's just going to load one root QML file, which was the main.qml I mentioned in the previous slide. And you're possibly going to need some sort of fallback mechanism in case you're unable to load the QML code over the network. Possibly fall back to a fixed version of your QML and resources, which is bundled with the application, so that so that you actually have something to display to your users. One thing we found which was quite useful was to give the application a distinct user agent, because otherwise you're just going to be Mozilla/5.0, which in your logs, in your server-side logs, is not really going to help you track the usage of your different versions. or if you need to I don't know, work around some kind of bug which is in a specific version of your application, you need some kind of handle to identify the different versions of your application. QtWebKit, okay, already has a user agent. If you use QtWebKit within your QML application, it already has a user agent built using your Q application's name and version. This, from the talk that Simon Hausman gave yesterday, is probably not relevant. Is not relevant anymore in QML2, where you no longer have a custom Q network access manager. You possibly need to specify the language which your user is running the locale on his computer. If you want to serve, let's say you have some server-side logic which actually generates QML code, which is possibly if there are some hard-coded strings in there, but which need to change depending on the language. It's always nice to have basically this checklist. Are not things which you absolutely must do, but it's a whole lot better to do it beforehand, and once you've deployed the application, you realize that you're missing these things. One thing you absolutely need is to set up a persistent network cache. So I'll be talking about that, and possibly configure HTTP pipelining if you want to reuse HTTP connections to minimize the number of the number of sockets you're opening to your server. I mentioned caching. So QtQuick has an in-memory cache for the components, and okay, also for pixmaps, but this is something which is not persistent. It's just in memory. So when, let's say, your button component is instantiated, whether it's once or a million times, QtQuick has a cache of this, and it's not going to be re-requesting your component or even regenerating code. It uses a caching mechanism. QNetwork Access Manager supports the standard if modified since header, so whereby it asks the server, give me the content of this, say, QML file if it has been modified since this date. That's fine. Okay, let's say this is interesting, but if you don't have a persistent disk cache, well, there's nothing to compare against. So you're going to be re-requesting the same files every time you start your application. So at some point, if you need to do all these different customizations on the Q Network Access Manager, the way this is provided, you need to define a factory which creates Q Network Access Manager whenever when QtQuick needs it. So, for instance, this is just some code for setting a Q network disk cache. I mentioned HTTP pipelining. What's HTTP pipelining? Since version 1.1 of HTTP, you can have multiple requests which are sent through a single socket, and the server is going to reply. Is going to serialize its replies and send them all back through the same socket. This has been available for a long time. It's not typically used in web browsers because it's subject to head-of-line blocking. If let's say if the first document you request on a socket is something which takes 5 seconds to generate, all the other requests which have been serialized behind this request are going to get blocked, and so it kind of kills the benefit which you were expecting from this technique. If your QML files are just static files which are being served by the server, you know what you're requesting, you know you're not going to be subject to head-of-line blocking, so you can enable, you can make use of HTTP pipelining, which is especially useful if you've got high latency links. So I'm thinking of radio, basically wireless connections. Qt5 already does this for you, regardless of what kind of resources you're loading, whether it's QML images or fonts or whatever. It does it for you. In the case of Qt4, it does it for pixmaps and fonts, but last time I checked, it doesn't do it for your actual QML files. So if you do need to enable HTTP pipelining, I can show you a piece of code later on. You need to once again subclass QNetwork Access Manager and provide a factory to your a factory for Qt to use. In terms of offline use, this unfortunately is a bit of a tricky part. It's easy to, let's say, when you start loading your initial QML file, it's quite straightforward to look at whether loading succeeded or failed, and if it failed, just to fall back to some embedded QML file. So that's easy enough. Unfortunately, if the network is up when you launch your application and when you load your initial QML files, but then the network goes away, that's a whole lot harder to catch, because when you're going to let's say need to load additional QML files, it's going to fail, but it's no longer it's no longer the initial file which you loaded from your C++ code, and so okay, this unfortunately is one of the cases where it's going to be a bit hard to handle. So if someone has some clever ideas revolving around this point, be quite happy to discuss it with them, because so far I don't have a solution for this. So we've covered so far the application, let's say the loader part of your code, which is written in C++. You also have you're also going to probably have plugins to expose additional objects. So I'm basically repeating what I said previously. If you can keep the C++ code simple, do it. Don't start putting UI logic into your C++ code. If you've decided you're going down the QML road, do it fully. And try and keep your API stable, in the sense that this will enable you to have the same QML files for different versions of your C++ application. So as far as the actual QML content is concerned, there are some idioms which work for local files and which are not going to work for remote files. I don't know, how many of you have used the Qt.create component method here? Okay, so for the rest of you, this is if you want. QML is declarative, so usually you're explicitly going to declare the instances of your components, but in some cases you want to populate something dynamically, and the repeater maybe doesn't do the job. There are cases where you're going to want to dynamically instantiate a component, in which case you can use the Qt.create component method, which takes a URL, which is the source, and then once you've got this handle on the component, you can create instances of it. Unfortunately, the simple 2 lines of code at the top are not going to work in the case of if you're serving your QML over the network, because once the first line is executed, you have a handle on the component, but it's not necessarily, and it's usually not going to be loaded, and so the second call is going to fail. So you need something slightly more complex. This is pretty well explained in Qt documentation, but basically you need to you're going to have to watch the status of your component to determine whether you can go on to the next step and actually instantiate this component. Along the same kind of lines, you're in an asynchronous world, so you don't know exactly when things are going to be loaded. So you have to review some of your timing assumptions. If you made assumptions on the fact that certain objects are going to be loaded in a set order, this is already something which is not a good idea, but you're probably going to get away with it with all your QML files locally. But if you're loading over the network, this is sure to fail. And one of the tricky points is when you're using component.onCompleted to run some kind of initialization code, watch out, because let's say you have a parent element with children inside it. The order in which these different uncompleted signals are going to fire is not defined, so don't pretend it is. Another point, okay, I mentioned ways to kind of reduce the impact of having many HTTP requests using HTTP pipelining. This kind of mitigates the problem, but if you have millions of icons to load, it is going to be noticeable when your user runs its application. One of the kind of fun things which we did in our application was to do something which is done in the web world, which is to use a font for icons. So in this case, Font Awesome, which is how many of you know what Font Awesome is? Anybody do web development? Okay, well, basically it's a font which comes along with a Twitter Bootstrap set of files, which are some CSS files. It's a font which gives you a number of icons, and so you can just declare a label, let's say a text element in QML, tell it to use the Font Awesome font, and you can and then depending on the Unicode character which you give as the text for this element is going to display such or such an icon. And one of the nice yes. You could do that. That's actually another thing which I was that's another method which we were considering. You could bundle QML files and resources, but then you still need to have some kind of if you're going to use an external resource, which is kind of what you're describing, because I imagine you want to still serve it over the network, you're going to have to write some kind of C++ code to help you, well, load this resource. But that's if we come up with an API which makes sense for everybody, yes. But at the very least, it could be mentioned in the form of documentation. But that's a valid point. I mean, caching is nice, but it's still, I mean, you still need to load them initially, and periodically, whenever the cache expires, you're going to have to recheck all these files. I mean, it really depends on how many icons you have. The QtQuick does a good job of loading these files asynchronously, so they're going to just appear progressively in your application. But it can look messy if I don't know, if you have a toolbar at the top and you're missing half the icons, they're only progressively showing up. It's all a question of how many you have to load. Okay, and finally, I wanted to touch upon the subject of actually deploying your application. For people who come from a web background, this is probably not going to be very exciting stuff because it's all pretty run-of-the-mill. But okay, one of the nice things of serving your application over HTTP is that you can leverage all the infrastructure and all the tools which already exist and all the skills possibly of the employees of your company. You can, to host your QML code, you can either run your own servers, you can use cloud services to store them. You have all the usual load balancing and failover mechanism which come with HTTP. And your QML files can either be static, or if you want, you could even generate them on the fly. Let's say, I don't know, you have users which have different types of subscription. Maybe they don't have access to the same, let's say, to the same user interface. You could do something on a per user basis and serve different files for them. When you start deploying your application, you're going to have to decide on the URL which you use as the root for your application. What we did was that we decided we would version the URL depending on, let's say, the version of the C++ code, because some features some new, let's say, some new APIs become available in the forms of new plugins, and some are possibly deprecated, and so at some point you're no longer able to use the exact same QML code to cover your different applications. Say at one point your version 1 is what you're currently running. You can do incremental fixes on it, and at some point you're just going to have to break compatibility and move on to another version of your application, which exposes, let's say, some new data model, and so you're going to need to decide on some kind of a naming scheme, some kind of a scheme for your URLs. You could alternatively do a switch on the user agent, but then this means that you're creating server-side logic where you could have just had static files, which is quite a bit simpler. One issue you might run into is a sort of consistency problem related to caching. To try and explain this, let's say I have a dialog file and a button file, and they have a certain, I mean, the button has a certain API at some point in version 1, and I go ahead and change the way this button element works in a second version, and so the dialog which uses this button is going to need to change. You might end up you might end up in a situation. The hatched areas are, let's say, the lifetime of the element in cache. So you set an expires HTTP header describing how long this object is allowed to be maintained in a cache, just like you would do for a browser. Your user launches the application, the dialog, say a dialog comes up, and based on some event, the button is only created later on. So even if these two components have the same expires duration, if the user restarts the application, let's say he's going to end up with the new version of your dialog, but still the old version of your button, in which case it's going to fail. So one way you can work around this is that if you need to have a coordinated update of your different files, you could just structure your file tree in a way where all your QML files are behind a release identifier. So to say that you have your main.qml, which is at a set URL, which your clients come and pull or come and pick up, and this main.qml then goes ahead and loads a dialog from a subdirectory containing a version ID. In which case, if you have a change which kind of breaks, you can just change the release ID, and then your button and your dialog are going to come from the same version. This is more of a in our use case, our users do not relaunch the application very often, so we kind of forgot about this problem, but you have to be aware that it can exist. In terms of security, well, what are we doing? We're serving code dynamically. We're serving code which is going to be executed on the user's computer. The least you need to do is to at least ensure that you're not going to be subject to DNS hijacking, let's say, on some kind of a hotspot, possibly here. Maybe someone malicious is going to intercept your HTTP requests, requesting the QML code, and send you some malicious code instead. The very least you can do is to use HTTPS to ensure that you are talking to the server which you think you're talking to. Make sure your certificates are valid, because Qt quite sensibly is strict by default about validating the certificates. Possibly on some embedded platforms, you're going to need to ship your own root certificates if you're using a provider for your certificates whose if you're using a certificate authority which is not in the default bundles, well, okay, you're going to need to ship it yourself. A couple of just quick performance considerations. Settings which you can do on the server side. It's well worth enabling gzip compression for QML and JavaScript files because these are text-based files and they compress very well. Unfortunately, if you just take your out-of-the-box Nginx or Apache configuration, it's not going to know the MIME type of a QML file, and so it's not going to take the decision to compress them. So you're going to need to declare some fake and MIME type for your QML code and enable gzip compression. This is really cool because you're going to typically get at least a two times compression ratio. I mentioned the fact that QNetwork Access Manager knows how to handle re-requesting a file and asking if it has been modified since a certain date. This is nice, but this does require a request and a response. So basically, if you fire up your application, you've got your persistent disk cache, which is set up, but if no expires header has been given with when the QML documents were initially served, QNetwork Access Manager has no way to know that these files are still valid, so it's going to ask the server, hey, give me this file if it's been modified since this date. So the server is only going to come back with a short reply saying, hey, it hasn't changed, but still it's going to cost you a round trip for every single one of your files. Another, I mean, this is once again, this is pretty run-of-the-mill for web developers, but this is not necessarily who we are in this room. Consider serving your static files from a cookieless domain because cookies do incur a little overhead, especially if you have large cookies. This is something which is sent with every single request that QNetwork Access Manager is going to do, and so you ideally want to serve your code from a cookieless domain. How are we doing on time? Okay. Are there any questions at this point? I mean, if you want, I can show you some code which illustrates what I've been talking about, or even the application. How do you want to do it? Okay. So one of the things I mentioned was the fact that if you have some customizations like setting a user agent or setting up a persistent disk cache, you're going to need to either subclass Network Access Manager, or at the very least have a factory which creates these Network Access Managers for you. This part right here is where I set a user agent. I have a function at the bottom, a method which defines my user agent, so that it gives me information about the version of the OS which the person is running, the version of our application, all that. And so it's to put this into place. Well, I need to override the create request method, and whenever a request is about to go out, I'm going to modify it by adding a user agent if it doesn't have one. As I said, WebKit is already going to set one, so I don't want to break that because it gives valuable information about the WebKit version. So if there is no user agent, then I set one. Right here, I'm enabling enabling the HTTP pipelining. And yeah, I'm setting the language which the user is running. Okay, this is probably about all there is to say about this. Yeah, I mentioned the fact that you need to set your own Network Access Manager factory. This is what I'm doing in this line of code. And the retry logic, which I mentioned, we have something very basic. Is basically we just try and load a QML file initially from the network, and if it fails, this code is all open source. I'll give you the link. I'll give you the link before you leave, so you can just go and do a git clone and pull this code. So don't worry about taking the pictures; it's fine. Yeah, this is kind of where we start loading our QML file. There's a different QML file, root QML file for Migo market, and then a standard one for all other platforms. And depending on whether loading has failed, we either use an embedded version or the normal root URL. And we connect to the status changed signal of the Q declarative view, because this is Qt4 code. And if loading failed, then and this is the first failure, well, we're going to retry, but with the other. This is not the most beautiful code, I have to admit, but anyway, if we fail to load from the network, we're going to fall back to the local version, and if the local version couldn't be loaded either, we're just going to quit the application. I don't see why this should happen, but I mean, otherwise you're just going to have a ghost application with no UI running. That's that. And if you want to know what the actual application looks like, this is it. And it's been okay. It requested, if I were to run a Wireshark, you would see that it's, what's this shadow? It requested its UI over the network. And I mean, if I go and load this dialog, okay, maybe you just saw briefly the layout changing a bit as it was requesting the elements. If I go into a sub, okay, this is a little bit too fast. And yeah, here you saw the layout changing just a bit as it loaded its element. And the font-based icons, which I were mentioning from Font Awesome, are, well, all these dark icons. And the really cool thing about using a font for your icons is you can just change the color. If you want your icons to look pink, if you want them to look green, or if you want them to look slightly gray, as we have here on the side, no problem. Okay, well, I guess in the end your stomachs went out. So